How to find if a tree is a binary search tree. A binary search tree, or BST, is a tree that satisfies these properties for each node. So the left branch needs to be smaller than the right branch. No, the left branch needs to be smaller than it, and the right branch needs to be bigger than it. So you have a minimum. So 4 starts with a minimum maximum of infinity and negative infinity, since since it's a first value and there are no restrictions to it. So when you go left, the minimum is still the minimum from here, which is negative infinity, and the maximum would be 4. Then when you go to the right, the minimum would be 4 and the maximum would be infinity, because this one needs to be bigger than it and this one needs to be smaller than it. This is not a binary search tree because 5 is bigger than 4 and 6 is smaller than 8. Problem statement: the input is a tree and the output is a boolean, which is true or false for if the tree is a binary search tree or not. So how to build a tree? You create a class called node where you initialize the data. So each node has a left and right pointer, and by default it will be none, but you can assign a node to it. So like here, you assign the left of the root to be 2. So we create a function called isBST where we pass in the root and the minimum and the maximum. Since the root isn't none, then you do nothing for here, and then you see if it's in between negative infinity and infinity. And since it is, then you move to its left, where the minimum stays infinity and the maximum will be 4. And then so for 2, since it is not none, then you evaluate to see if it's in between infinity and 4, negative infinity and 4. And since it is, you move to its left again. And then for 1, since it isn't none, then you do nothing. And since it's in between negative infinity and 2, then you move to its left, which is none. So then that returns true, and then you backtrack back to 1. And then you go to its right branch, which is none. So then you return true and you backtrack back to 1, and then backtrack to 2. So then you move to its right node, which would be 3. So then you pass down the minimum of 2 and the maximum of 4. Since 3 is in between 4 and 2, then you look at its right, the left, which is none. So then you backtrack back to 3, and then the right, which is none. So you backtrack back to 3, and then you backtrack to 2. So then now, since 2 is in between infinity, negative infinity, and 4, then the left branch is a binary search tree. So then you backtrack back to 4. And then you move to 4's right, where you pass down the minimum of 4 and the maximum of infinity. So then, what you do is you move to its left, which is 6. So then you pass down the minimum of 4 and the maximum of 8. Since 6 is in between 4 and 8 and is not none, then you look at its left, which is none, and its right, which is none, so you backtrack back to 8 again. And then you move to 8's right, which is 9. So then the maximum would be 8, so the minimum would be 8 and the maximum would be infinity. At node 9, since the root is not none, you do nothing, and then you look, and then it's in between 8 and infinity, so then you go to its left, and then right, and then back to 8. And since all the nodes are processed and there is no violation of the binary search tree properties, the function isBinary search tree will return true. Thank you for watching.